Hey everybody, I'm excited to start a new unit with you. We are moving into Chapter 3. Chapter 3 is going to be about systems, systems of equations, systems of equalities, and finding when those systems and where those systems have solutions and what those solutions are. I've redone this video because, to be honest with you, we need more work with our word problems and we need more work with just our algebra, basic algebra skills. So I thought, hey, let's revamp the whole thing and start over. We're going to combine two lessons into one, primarily because they should be one lesson, because they both talk about solving linear systems, and there are three different methods. As you progress through, you're going to see that one method is solving using graphs. I avoid solving using tables. However, you are more than welcome to research that. I personally don't think it's a great way of solving. So we're going to do what I think is best so that we meet the standards and can move quickly through. And then we move into how to solve them algebraically. That's where words like substitution is going to come into play and words like elimination are going to come into play. Now let's talk about part one. And you can see where the state standards are right there. It's, the law. We have to learn these things. It is what it is. I personally love these. Part one, let's solve a system by graphing to see where in the world they intersect. We're not going to say the word cross because that is not a mathematical word. We're going to say intersect. I purposely came up with new problems here. We're going to follow these steps. This is a system because I have more than one equation. They are linear. So to do this by graphing, number one, we put both equations into slope-intercept form, which is y equals mx plus b for your vocabulary skills. Let's take a look at equation number one. Negative 2x plus y is equal to negative 4.5. To get that into slope-intercept form, I add 2x to both sides. That results with y equals 2x minus 4.5. Please get it in the correct, put the x first. And y is now by itself. The second equation, I'm still in step one, is to get this one in y equals 2y minus 11 equals negative 1x. To isolate y, to get it in slope-intercept form, I add 11. My new result is 2y equals negative 1x plus 11, and I'll divide every term by 2. This will give me y equals negative 1 half x plus 5.5. You may notice that I chose to use a decimal here and a fraction here. That makes graphing easier. Please pause the video and catch up to me if I went too fast. Step 2, graph both equations. I'm going to graph the blue one first. I'm going to go to a y-intercept of negative 4.5, and I'm going to use the slope of up to right 1, up to right 1, up to right 1. I will always note the students who listen to the notes because you are going to hear me say that I highly encourage you to go the other way and to use as many points as possible with your first line. So those of you who are listening without volume may not catch on to that. It's because we need to be as accurate as possible because we need to see where they intersect. We don't want to guess where they intersect. Now it's time to graph that. I will go to 5.5. That's positive. Excuse me. And my slope was, what was my slope? Down 1, right 2. Down 1, right 2. Down 1, right 2. Once they meet, you're done. You have found the intersection. You have found the solution. So my solution is over 4 and up 3.5. I believe in showing you how that's the answer. So if you're catching up with me, go ahead and keep graphing, see where they cross, or put me on pause, or put me on like a slowdown. You can do that. And I want you to see why 4, 3.5 is the answer. On my calculator, if I plug in 4 for x and 3.5 for y, you will see that it fits the first equation. See the blue equation? That's what I typed into my calculator. I proved that it worked. Now I'm going to go ahead and I'm going to type something into my pink equation. Trying to get my colors here. Here it goes. Look at my calculator. 2 times y, so 2 times 3.5, and minus 11. And that should equal negative 1x, which is negative 1 times 4. So you can see it fits the pink equation and the blue equation. That's also a really easy way to cheat on a multiple choice test. You can plug this in for x and that in for y, and whichever one gives you true solutions is your answer. Now, if you want to, you can graph this one, and you will see the solution is at 2, negative 1. So if you feel like you need more practice, please do that, and let me know if you need help. There are special cases that happen. Sometimes the lines don't cross. Or sometimes they cross, they're the exact same. Or maybe they're what we just had. Okay? So this is a beautiful visual of what we might come across as answers. I call this one and this one the special cases. Okay? Because the special cases have special answers. Now, if you have intersecting lines like we did, remember we had that in example 1, you're going to see they cross at one point. That's why they have one solution. They are called consistent because they have an answer, and they're called independent because they're independent of each other. The slopes are different. So if you see slopes that are different, you can assume it's going to have one answer. Now, sometimes you go to graph and you'll graph one line and you'll graph another line and they're the exact same. That's what happens when you have infinitely many solutions. So there's infinite number of x's and y's that satisfy the intersection. Because there is technically an answer, we call it consistent, but they are dependent because they are the same. The slope and the y-intercept are the same. So if you have the slope and the y-intercept the same, that means there's infinitely many solutions. Well, sometimes you might graph things and you're looking for where they cross. And you have this first line that I just made in blue. I'll highlight it instead. I'll highlight it in purple. And then you have the second line. I highlighted it in red. And they don't cross. So where do they intersect? I can't spell apparently. Intersect. The answer is nowhere. They have no solution where they're the same. So we have this fancy word called inconsistent. The slopes are going to be the same as each other, but the y-intercept would be different. So if you see the same slope with a different y-intercept, that means there's no solution. To recap, because I thought this was important to say, if you get them to intersect, it is what we call independent. If they never intersect, we say it is inconsistent. I love vocabulary. If they intersect at every single point, like they're the same line, then the system is what we call dependent. Those are the key words. Now, let's say that we're going through this and you're like, do I have to graph these? No. You can, when the question looks like this, when it says, is it independent, dependent, or inconsistent, you can just look at the y equals mx plus b and use what I just taught you. Let's take a look at 4y minus 2x equals 6. I think my famous phrase is, let's take a look. If we're going to solve this, I'm hoping that you add 2x, and as a result, you get 4y equals 2x, not 8, plus 6. Divide by 4. Y equals 2 over 4. Now, some kids still have not learned how to use that calculator, but I think you really should. Okay, so look, 2 over 4. If you can hit math, enter, enter, in case you're not sure, that's 1/2. And then I like that as a decimal. 6 over 4 is 1.5. And maybe just so I don't look like a goofball, there, because that would be horrible to redo this at 1.5. I'm not going to graph that. What I'm going to do now is I want to look at 8y equals 4x minus 12. divide by 8, divide by 8, divide by 8. 4 over 8 on my calculator would give me 1/2 minus, let's take a look at 12 over 8, minus 1.5. Now, you might think, boy, those look really almost the exact same, and you'd be right. But here's what we're going to state. We're going to say, hey, they have the same slope, same m, but they have different y-intercepts. So using this beautiful little chart up here, I can see that those would be parallel lines. And because they would be parallel, I would say they are consistent from the choices up here. Now, if you want to do another one, you're like that, okay, Miss Langella, oh, by the way, when would these be dependent? If this was a plus, then they would be dependent because they would be the exact same. Okay, if you want to look at this one is a dependent one if you want to give it a shot. Okay, so that's your got it if you need some extra practice. Part 2. Time to now solve a system, but we're going to get more mathematical and we're going to do it with substitution. Substitution is definitely a skill in every math class from here on out. I use it in physics all the time. You are going to follow these 4 steps where you solve for a variable, substitute it in, find it, and then go back and plug it in again. But what's new this year is the word problem. It's not good enough just to be able to be good at math. We have to be able to be math literate. Ramon wants to plant cucumbers and tomatoes in his garden. He has room for 16 plants, and he wants to plant 3 times as many cucumbers as tomatoes. How many cucumbers and how many tomatoes should he plant? The variables I would like to use, now some people are just like, no, I'm using X and Y. I'm not. I'm going to use C, and it's going to represent the number of cucumbers. And I'm going to use T, and that's going to represent the number of tomatoes. That's what I'm going to use because it makes sense in the problem. As you read through, it's important that you're able to pick out the key phrases. The fact that he has room for 16 plants, and you can see I highlighted that as important. That tells me that my cucumbers and my tomatoes total 16. And you might be, hey, I can't do that, Miss Langella. And I might say, hey, that's okay. Just keep practicing because I'm going to give you opportunities to practice. Now we're going to do this phrase. He has 3 times as many cucumbers as tomatoes. So cucumbers and tomatoes, he has 3 times as many cucumbers. So if you multiply tomatoes by 3, you will get your cucumbers. He has 3 times as many cucumbers as tomatoes. 3 times, yep, that's good. Yes, I do have a note here. A lot of kids will be like, I can do that in my head. And I like, great, that's awesome. I hope every problem in the world is a whole number for you and it's positive and you can do that. But like that doesn't happen. I purposely make the word problems easy at first so that you don't have to struggle with the math. But you should know how to do substitution. If you can't, then you've not met the state standard. So let's take a look at what we do here. Substitution. Number 1, solve either variable in either equation. All right, I'm going to get my equations. I'm going to bring them down here. Actually, I'm just going to duplicate them, and then I'll bring them down here. And I really would love to highlight this second equation. Do you see how, now listen to the vocabulary I'm about to say, please. C is already isolated. So I can take 3t and I can plug it in for C up here. So I'm going to draw an arrow like this, and I'm going to change colors. Now, please follow. It used to be C plus T is 16. Now, it is 3T plus T is 16. I literally took, let's take a look again. I took away the C, and I replaced it with 3T because this equation said I could do that. I'm going to put my fence on. I'm going to combine my like terms to get 4t. I'm going to divide by 4. And I have an answer for tomatoes. So what is this? Tomato plants. I have now made it through step 1, which is already done for me, step 2, and step 3. Step 4, I'm going to plug that value back into the other equation. So when I say into the other equation, I mean the one that I didn't, like not this one. See the one I highlighted in yellow? Not that one, because that's the most recent one I worked with. I'm going to plug it in right here. And I'm going to go ahead and use black for that. So I'll draw another arrow, boop, 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 boop. C equals 3 times 4, 12 cucumber. Cucumber plants. Again, I understand that there's probably enough of you out there who are telling me, I can just do that on my head. That's great. Okay, that is really great. However, you won't be able to on harder problems. So you have to learn the process. Let's do the process with an easy problem and then step it up. Now this one down here, the next one is just a got it. If you want to try it on your own, look at those ugly answers. And then this one, yeah, try doing that in your head. It's 17/11 and 26/11. So if you want to try those two, there's nothing wrong with that. In fact, I would really encourage you to try this one. And let me know how it goes. Because if you get that one wrong, again, you've not met your state standard objective. Let's talk about it's probably just a negative or a positive. All right. Let's try part 3 now. Part 3 talks about elimination. This is also called the addition-subtraction method or linear combination. Elimination is 100% a skill that's useful in every math class. I don't care where you're going after this, you will use substitution or elimination. I do it in physics, we do it in trig, we do it in calc. We do it all the time now in Algebra 2. Okay, so this is actually an Algebra 1 standard, so we're just refreshing that standard, bringing it back so we can use it where we need to. Most kids are most comfortable here. I'll say most comfortable. In fact, sometimes your teachers tend to push you that way. However, you really at this point should be able to say, I'm comfortable with all the different methods. I can see that this one's good for substitution. Maybe there's a variable already isolated, and this one's good for elimination. Maybe they're both in standard form. I'll go ahead and put that on there. When they're both in standard form, and if you're not sure, that's ax plus by equals c. That's a really good time for you to use elimination. You'll multiply one or both the equations by a constant so that you can cancel out a variable. You'll add them vertically, you'll find a variable, and then you'll substitute that back into one of the originals.